Now we're going to talk about fossils. Fossils is just any naturally preserved evidence of life. That's it. Just any kind of a clue that there was definitely life that came before you. So that could be a bone, it could be a tooth, it could be the imprint of a footprint or a leaf, something like that. All those things count for fossils. Now, when we're talking about bones, the bones that we find underneath the ground, they form in a very interesting way because what you're holding in your hand, if you hold the dinosaur bone, is not the actual bone that was inside of the dinosaur. Not normally. Instead, what happens is this really interesting process um, where minerals from water. So if the bone is inside the ground, okay, let's say that here's the animal right there, and water trickles through the little openings inside of the dirt right there, and that water contains minerals that it absorbs from weathering and erosion and just picks it up along the way. And what happens is that cavities start to form inside of this bone. Just the way like if you don't take care of your teeth, you get cavities there too. Little tiny microscopic holes. And those little minerals that are carried inside of the water fill in those cavities until the entire original skeleton or the entire original bone is replaced bit by bit, piece by piece, by all those minerals. So what happens is that it's the exact shape of what came before, and it can give us tons of information about the exact shape of what it was, how big it was. You know, you can find one little bone, and that can tell you so much about how the entire creature may have looked. However, what you're holding is almost like a replica of sorts because it's the minerals have been replaced in that entire time. But it's a little bit of a side. We still call that. We'll still say that's a dinosaur bone, and because it's the exact shape of what it is. So these only happen in sedimentary rock. Any other type of rock, igneous or metamorphic, would destroy the fossils. Because if it's igneous rock, the only way igneous rock can form is if a rock melts down into magma, and if that happens, any evidence of something that was living inside of it is now gone. And the same thing would happen with metamorphic rock. It forms from heat and pressure. That heat and pressure would crush and destroy all evidence of life that's there. So only sedimentary rock has fossils inside of it. Now, uplift and erosion make them easier to find. If you have an area where there's going to be lots of bones buried there, you're going to have to dig through there, right? But if erosion happens there, it's like doing some of the digging for you. So it helps expose some of those areas you may not have been able to get through. Also, some of those fossils are deep inside of the ground. Uplift happens when two different tectonic plates come together and it pushes parts of the ground up. So when that happens, bones that were deep inside the ground can get carried up to the surface in that way. So that would be an example of uplift. Couple different ways that animals can become fossilized. One on the left here's a smilodon or a saber-toothed tiger. And there are certain places called tar pits where that tar is very, very, very sticky. And if you are an animal that's unfortunate enough to get caught in one of those tar pits, you could still be alive and just there's no way to escape getting out of it. It's kind of like quicksand. And then you're just caught in there. And then there are certain tar pits where they've found tons and tons of bones inside of it because animals are unlucky enough to get stuck there. You might imagine that I know this is a predator here, but imagine a prey animal got caught in there. The predator may not be able to resist going in there and try to get that easily attainable prey, and then it gets caught as well. So both wind up dying there. And then the tar winds up really preserving the bones nicely in a nice, easy way. Because if the bones are just out on the surface somewhere, just most likely the decomposers or scavengers are going to take all that stuff away. You have to get very, very quickly for you to most likely survive the test of time and then become a fossil. Let's say that like less than 1% of all animals that have ever lived become fossilized. It's a tiny fraction of those. And it's from those fossils that we do find. Now keep in mind, it's a tiny fraction of animals that can become fossilized, and then we only find a tiny bit of fossils from out of those. So there's a lot more animals that existed. Every time we find a fossil, we're like, oh, there must have been a lot more of these that actually existed. We just haven't found them yet. Here you have a mosquito that's found in amber. So the amber is like a tree sap like thing that comes out of the tree, and then if it gets caught inside of that sap, it will preserve the shape of the body there. Now, if you've seen the movie Jurassic Park, they made a whole movie based on this idea where they found a mosquito inside of amber. That's the fake thing from Jurassic Park, the movie. So they drilled inside of the mosquito, they took out dinosaur DNA that the mosquito bit, and then they were able to use that to replicate dinosaurs. Now, two reasons why that can't work, even though it's an awesome idea, is that apparently if you were to drill into the mosquito here and you were to extract DNA from it, you would get mosquito DNA, not dinosaur DNA. The other thing is that even if it did have dinosaur blood inside of it, DNA is readable in the past for about a million years. And last time we checked, the dinosaurs were not here for about 65 million years ago. So it's impossible for us to recreate Jurassic Park in that way, even though it might be cool, might be foolish, who knows. If you look over here, just a couple different things that can happen to the fossils. So the fossil layers, remember we talked about how you can determine the age of a fossil based on the layer that it's in. But know that if there's a fault, one layer can shift up relative to another one, and then the fossils may be out of order. So you just have to make sure that you put them back in the right order. You have to mentally fix them so that it looks correct. Over here, we have an intrusion, a magma intrusion. Any fossils that may have been in all these layers right here were just melted away because of that magma intrusion. So that's another thing that can destroy fossils. Now, a paleontologist is a scientist who winds up studying these fossils. And, obviously, that would be like your dream. If you were a paleontologist, you want to find a perfectly preserved, hopefully a big dinosaur. I just can't think of anything cooler than being able to do that. Now, let's say that you were a paleontologist. Which of these areas would you then dig for fossils? Now, look at all these different places right here. Which one will be the best one? What do you think? So let's go through one by one. We have a city right over here. That's Central Park in New York City. We have the bottom of the ocean. We have the Arctic tundra, let's say Russia or Alaska, somewhere there. Here we have the middle of the jungle. Here we have a volcanic island. Here we have a canyon, like a dried up riverbed. Here we have a mountain range, a folded mountain range. And then over here we have the desert. So the city, not great. People live there. There may be dinosaur bones underneath there, but who's going to give you a permit to dig inside of there where people are living? It's unlikely that you'd ever be able to. Plus, you can't, like all this land is protected. You're not going to dig up the middle of these buildings, and nobody's going to allow you to dig up Central Park. So that's a no. The bottom of the ocean, there might be some really good fossils there. However, how are you going to get down there? It's almost impossible to get to the bottom of the ocean, and then you're going to dig underneath all that to get there. Very unlikely as well, even though there might be tons of fossils down there that we just don't really have access to. Over here, we have the Arctic tundra. Think, this is frozen ground. Good luck digging through that. It's going to be very, very difficult to get through there. So not an ideal place. Over here, you have the riverbed. And now we know that some dinosaurs have died inside of riverbed areas, so maybe, but there's so many trees over here and all those roots that you'd have to dig through. It'd be very difficult to dig through that area. The volcanic island, you might find some. However, except for the fact that the volcanic island is going to be mostly igneous rock. Igneous rock destroys fossils. Over here, this is your best bet. You can tell that it's sedimentary rock. I mean, look at all these layers right here in the rock that you could tell right there. Not to mention, the erosion has been done for you. So that's great. Now, whereas this is like pressing into the ground, like a depression, this is coming out of the ground. This is going to be very difficult to dig through right here, this mountain range. There probably are some fossils deep down there, but how are you going to get to them? It would be really difficult. Not to mention, because of the folded mountain ranges being squeezed together, that most likely is a lot of metamorphic rock that's right there. Metamorphic rock doesn't contain fossils, so that would be no good. And then this last one is a bunch of sediments. Now, just because it's sediments doesn't mean it's sedimentary rock. It's not really totally clear where you would dig right over here. There's no indication of where you'd start. Now, it's very much more likely that you'd find fossils here than most of these other places, except for here. I'd say this area right here is the best one. This is probably the second best one, but really, if you were here, I would try to look for like a sandstone formation and try to dig in there rather than, just a loose sediment.